Okay, thank you very much. Hi, everybody. My name is Oleg Lodygensky, and I am very pleased to introduce Café, a new project that I'm developing. Café is a crypto agility framework for Ethereum. Café aims to industrialize the necessary cryptography migration for the Ethereum blockchain. In this presentation, in this 20 minutes, we will see that cryptography is at a corner, and we must migrate to new cryptography. You will see why we must migrate. And then we will see that Ethereum ecosystem is working hard towards this migration, and we will detail what must be migrated. This will lead to my subject, where I argue that we need a tool to industrialize the necessary migration, and finally, the roadmap will permit to understand when we must migrate. So cryptography is based on some mathematical properties that permits, given a secret, to publish some data. And given that public data, it is almost impossible to retrieve the initial secret. This is the base of the Ethereum security. Cryptography exists for very long, and we have a good view of the cryptography, let's say, life cycle. We know that time to time, a cryptography migration is necessary because new science, new technology pushes the current cryptography under pressure, and this is exactly where we are. We are at the point where a new technology is emerging. This technology is namely the quantum computer, and the quantum computer push this our current Ethereum cryptography under pressure, and we have to migrate. Luckily, some new mathematical properties have been elected to write the new cryptography algorithm, and some of these new cryptographic algorithms have been elected and published as the new standard by NIST in the USA. So this is the base. These new algorithms are the base of the Ethereum ecosystem work. But I mean, these new algorithms are somehow, I would not say the simple part, but the first step only towards the migration. The question, the first question, what algorithm should we use now to resist the quantum threat is answered somehow. But next question arises. How could we migrate the cryptography for Ethereum? If we migrate and when we will migrate to a new cryptography, what are the consequences for the decentralized application, for the wallet, for everything? If we change the protocol, which is today, the protocol is written with a fixed cryptography. We cannot change ECDSA just like that. It is not possible. There are some solutions, but by itself, in the protocol, the cryptography is set once. And if we change this protocol, there are a lot of decentralized applications that are written against this protocol. We can think, of course, about DeFi, NFT, SBT, DID, a lot of things. Bridges are also written using this protocol and its cryptography. So that if we change the protocol, we must, of course, audit all the decentralized application. Not all the application will need to be migrated because some of the application, decentralized applications, do not use some specific function, so they could stay like this. But of course, the decentralized applications that uses the cryptography part of the protocol will have to be migrated. And if we migrate them, if we migrate the Ethereum layer 1, let's say, of course, all the other networks must be migrated too. It is a waste of energy let's say, to ensure new security for Ethereum if the other part does not comply to this new security. And at the end, of course, the end user, we are all end user of Ethereum, I guess. Even we can be developer or I don't know, or users only, but we always use wallets. And this wallet must also comply to this new cryptography. So it is a mess. There are a lot of things to change. It is not only the question to put another algorithm, but also we have to manage properly, to coordinate all these subjects and to ensure that globally the security is still ensured. We know that today we certainly have been to some panel here in ETHCC. So we know that the researchers, the Ethereum researchers, are working hard towards this migration. We know all the questions that must be answered, the question of a gas usage, the question of a storage usage, of a throughput, and all that. You also may have, you should be aware that there are new working groups that every Wednesday we are all invited to connect, to video call, to discuss, to follow the discussion. At least there are also a new website, pq.ethereum.org, so we can all easily follow what is going on. And the Ethereum Foundation published a straw map, you may all know that now today. And in the straw map, among others, the migration to the post-quantum cryptography is mentioned, and this migration should be done by 29, which is tomorrow. So we have to work harder today, from today. A lot of effort, a lot of suggestions, a lot of proposals are being processed. I mean, some of the solutions are already deployed. ERC 447, maybe 4337, sorry. Maybe you heard about that, or 7702. There are different levels. There are a lot of discussion, a lot of other EIPs that are under discussion. The stages, the level of maturity is not equal for all of this proposal, and it is quite complicated to follow all this proposal and to know what at the end will be really deployed and used. This is the question today. So all that is very interesting. We are very early. There are different directions. Some will be abandoned, certainly. And my point is that we must be able to follow quite easily what is going on regarding our threat to our wallet. So this is why I propose a tool, Café, that permits to implement the crypto agility. Crypto agility is a well-known process. Okay, so you can easily find information about documentation about crypto agility on different websites. And crypto agility is a way, is an automated, iterative, data-driven way to migrate the cryptography. So each iteration is done as, let's say, as three parts. The first part is discovery. Discovery is a tool that permits, Café Discovery is a tool that permits to understand, to retrieve all the information about your wallet, let's say, and to understand what is your attack surface. Okay, I call that blast radius, but finally the idea is that when you have a wallet, you must be able to understand. Maybe you use your wallet, you own some NFT, of course, some digital assets. You participate to, let's say, a multi-sig wallet or what you want, but everything is written on the different blockchain where you use your wallet, and the tool permits to retrieve all this information, so that you clearly know what are the consequences of all that, of using your wallet. And if your wallet is compromised, you can see what are the consequences of this compromission. When you have your attack surface, you are invited to go to step 2, which is to define a new cryptography policy. The idea here is the end user will have some options, so certainly it will also be able to define her own option, his or her own option. But at the end, you define a new cryptography policy so that you say, for example, you could say, okay, I want to leave ECDSA and I want to use that technology. Maybe today you could say, I want to use ERC 4337 or EIP, I don't know what. But you define a way to reduce your attack surface. This is the idea. And when your crypto policy is defined for that iteration, at each iteration, you will have an opportunity to modify your crypto policy so that you will have the possibility to follow the work done on the protocol, let's say. Okay, but for that iteration, you define a crypto policy. And when your crypto policy is defined, is written, then you can go to the third part of the iteration, which is remediation. And the remediation is the execution of the crypto policy itself. So you could say, for example, I would like to use, someone presented an EOA rotation system so that, which has, I mean, the beauty of simplicity. So it was very nice. And it is an idea, why not? You could say, I want to I want to use this EOA rotation system, and this would be written in your cryptography policy, and at the end, the remediation is effectively to use this system. And when this remediation has been run, you will be invited to go to the next iteration so that you will recalculate your attack surface, your blast radius, your risk score, and you can go to another loop. Okay? Because we know it is necessary, because the idea here, and it is very important, I think I did not mention that. something very important in this cryptography migration is that today we are in a fixed cryptographic system. Okay? There is no way we can, of course, there are some ideas, but basically, the signature algorithm in Ethereum is ECDSA dot. This is not a discussion. Okay? So the cryptography is written in the protocol itself, and this is ECDSA and nothing else. Okay? So the idea of the crypto agility is to move from this fixed cryptography environment to a more flexible one. Okay, at the end, we want to be able, this is exactly why I like EIP 8141, which introduces frame transaction, but this is just a parenthesis. But the idea is that we leave this fixed cryptography system toward a new flexible one, and at the end, we'll have the opportunity to choose the cryptography we want. And this is very good because what you must understand here is that the first iteration, where we are now, not me, but the Ethereum researcher, is very complicated because we must leave this fixed cryptographic system to propose a new flexible one. But when the flexible cryptography system will be put in place, then the next step will be just easier. Okay, so if for example, I am not a cryptographist, but if, for example, MLDSA does not fit the requirements, and we start using MLDSA, and MLDSA is not the good one, we will have the opportunity to easily change the cryptographic algorithm. Okay? So the first iteration is to leave this fixed cryptographic system to a more flexible one. And it is very, very important. This is why the first step is that heavy, finally. How it is implemented today, the Café discovery is already implemented. At the end, there will be a QR code to go to the service if you wish. The end user give his wallet address. The system is read-only, there is no risk about that. The system digs different EVM networks, and at the end, you have an answer, your wallet, this is your wallet. Okay, and your wallet is used for this, for that. Your wallet uses a signature algorithm. Of course, for the moment, it is ECDSA for sure, if it is an EOA. Lot of things. And at the end, I calculate a risk score just to have a good view of, a simple view of your attack surface. I am very interested. I think it is very important to use standards so that the system will be interoperable. And there is a Cyclone DX project that proposes CBOM. Cryptography bill of material, for those who know that. This is the equivalent of SBOM, software bill of material. Okay? This is the same idea. And the idea here, the advantage of using this standard, let's say, is that the system will be interoperable, of course. The Café discovery also proposes to retrieve the blast radius and calculate the risk score of your RPC endpoint. And this is very important, of course, because when you interact with the blockchain, you want to know what is the risk to use such an endpoint. Okay, so the system permits to retrieve the blast radius and the risk score for such things. So how it works today, it is first quite simple version. You give your wallet address, and the system retrieves information in different networks, 6 or 8, I don't remember. And at the end, you have a risk score. So this one, the risk score is very low because this EOA has never been used. So there is no way to retrieve the public key. This is the base of the entry point of the quantum risk. Okay? And this one, and if you click here, you go to Etherscan, of course. And this one has been found somewhere. I don't know where, but it has been used. And then the public key is exposed. And when you click one of these, you have the detail. Of course, the algorithm is always ECDSA. This day, Café, more than discovery, the next step, Café will propose some solution to reduce the attack surface of your wallet. There is, as I said, we will see the crypto policy management, and also the remediation. As I said, the discovery permit to retrieve, test SSL.sh. This is something just quite the same, okay? We dig your endpoint, mainnet.optimism.io. This is just an example, of course. And then we retrieve everything. Okay, so you know the risk regarding the quantum attack, the quantum threat, of course. Huh? You know the risk of using such an RPC endpoint. Okay, so here, this is very important. The Café do not and will not propose crypto policy management for RPC endpoint, neither remediation. This is out of scope. Okay, RPC endpoint is a question of infrastructure. I do not touch infrastructure. But at least it is I think it is very important to know what is the risk to use that input, not mentioning that you, when you define the crypto policy for your wallet, you will say, I want to use that algorithm, new cryptographic algorithm, a lot of things. Among them, you will have the opportunity to say, I want to use RPC where the risk level is lower than, for example. Okay, this is why I retrieve the RPC risk score. I calculate the RPC risk score. And at the end, you will have, this is not implemented yet. At the end, you will have, the end user will have a way to define, you will have several proposals to reduce the attack surface of his or her wallet. Also, this is not implemented yet, the remediation, but when the crypto policy is defined, you will have a way to reduce, to execute, your policy management. Crypto policy, to execute your crypto policy. I am not a cryptograph. I will certainly not propose any solution, but we could use EUA rotation K. I heard about Zcanox, Trezor, Ledger, thank you, Trezor, Ledger are implementing new, developing new HSM with including, that includes cryptographic, post-quantum cryptography. So this is exactly the kind of things the end user will be invited to do. Okay. And I think it is all, no, my roadmap, of course. So we are in 26. I started the project in the last autumn. I have to implement to continue to implement the discovery. I have to implement the first version of the crypto policy management and how to, I have to find, let's say, some partners about the mediation, of course. In 27, 28, I will continue to follow what is going on Ethereum and to follow the implemented EIP and what you want. And of course, I will comply to all that. Before we go to mainnet, as usual, we will have to do a security audit. And since the roadmap mentions that the post-quantum cryptography migration should be done by 2029, I follow that roadmap finally, just to be ready on time. And that is all for me. Thank you very much. If you have questions, you can access, of course, the website, and the GitHub are open. So if you want to participate, if you want to read how it works, you are very welcome. Thank you very much. Any question?
Thanks for the talk. Actually, I have one question. There was this Google announcement that they thinking that post-quantum cryptography, especially, I guess, related to Bitcoin, but I assume it also touches Ethereum, might be happening, that they might crack it in 2029. And after that, there were rumors that actually it might have been already cracked, and just Google gives a little bit of time for everybody to, is going to go live. So like, what if it is faster than 2029? What do you think we need to do, basically?
I think this guy is better to answer that kind of question. This is what you presented this morning. My opinion is that we should not, I mean, there are a lot of information. Okay, so what I understand this morning is that, and this is also what I read, that Google presented a theoretical solution. But between theory and put in practice with a hardware defined and developed and blah, blah, there are a lot of time. There may be some time to have this hardware. By the way, what I personally follow is, let's say, NIST. And NIST from the US, this is a National Institute of Standard and Technology. NIST says that by 13, ECDSA and RSA will be deprecated only. And by 35, it will be, you will have no chance to continue working with this algorithm. This is what I follow. I am French. I have been in France. In Europe, we have ENISA, which follow finally NIST. In France, we have ANSSI, which follow ENISA, let's say. And I have been to Banque de France and with a lot of big bank and insurance company, blah, blah. And the message was you should do the discovery now, because you must know now where you are regarding the quantum threat, and they mention 2040 and 2035. So I don't know what to think. If the thing certainly is that science and technology evolve. Sometimes a new technology suddenly is raised. Maybe it will happen. So we are in shit, to be honest. Otherwise, if we are not so pessimist, let's say we have some time. I think 29 for Ethereum is a good starting point. I'm not sure. I don't know if Ethereum Foundation will achieve this migration by 29, but at least fix a kind of challenge. Okay, 29, this is yesterday, finally. So fix a challenge is a good way to put the right state of mind to everybody. We must migrate now. So even if it is not possible today, but this is the idea we must keep in mind. I am right? I agree. Thank you. Thank you. Any question? Thank you.